The Sustainable Engineering team has arrived at MACH 2026. And we're looking forward to a busy day. We're going to be doing lots of on-stand interviews. We're going to be exploring things from machine tool efficiency, how robots are entering the circular economy in terms of refurbishment and reuse, things like recyclable tooling. We'll be looking at pneumatics and reducing energy consumption, all sorts of things, that and loads more. Okay, the Sustainable Engineering team is now on the KUKA stand at MACH 2026, and I'm here with Neil and I'm here with Max. And in the last issue of Sustainable Engineering magazine, we did a fascinating article with KUKA, organised by Neil, looking at how circularity principles are now being found in the robotics industry in terms of energy efficiency, in terms of maintenance, in terms of repair, upgrade, and reuse. And now we're here at the show actually looking at some of the robots themselves, in particular this machine right here. And I'm going to get Neil to very quickly introduce this particular machine, and then Max is going to give us a technical rundown on what makes it special and where we're going to find it. So Neil, just an introduction please to yourself and then this machine.
So I'm Neil Mead, Marketing Director for KUKA Robotics in the UK. We're really excited to be at MACH because it gives us a chance to showcase our large robots and the whole portfolio. And we've specifically brought over the new Titan Ultra to really show it to the visitors here this week. And I'm also really honoured to have the product manager for our large robot portfolio, Max, come over from Germany, from KUKA in Germany, and to be able to talk about the particularly the Titan Ultra and some of our other larger robots as well.
Brilliant. Okay, thanks very much, Neil. Right, over to you, Max. Yes. I'm going to open with my standard question, which is what sort of challenges would an engineer be facing for this machine to be the ideal solution?
Yes. First of all, Max Petkun, my name. Product manager from Germany, responsible for everything which is big and heavy, Fortec, Titan, and also linear tracks. What an engineer would this be a solution is honestly handling big and heavy items. That's what I see. Up to 1.5 tons we have now here, so 500 kilograms more of capacity, which is giving more flexibility in also that one. We also have two other variants which also have 1 ton payload with 4.20 meters in reach, which gives you also more flexibility in production designing and also everything else.
Yeah, yes. And so what makes this particular design special? What is it about the construction and design of this that separates it from competitors?
Yes, that's a super good question. We have here, based on our Fortec 2 Ultra family, we have here the double link arm system, which you see left and right side. In the Quantic base, we just have 1 link arm. Here now 2 link arm. It looks a bit bigger, but honestly, it gives us a much better place in the own weight, honestly. And of course, that robot is heavy, but we had made it really good to stay below 5 tons. And yeah, 5 tons is, especially in logistic and transport, a super critical limit, because all kind of forklifters, cranes, have the boundary of 5 tons. If you go above that, it's really like super hard to integrate, and it's not super easy to integrate. Of course, not super easy, but yeah, staying with here 4.7 tons in a super good range, that brings us in a very good position with that special big robot here.
Okay. So yeah, looking at it visually, you would imagine the 2 arms are increasing the weight of the robot considerably, but I guess it's improving the rigidity.
Yes.
So you can keep the wall thicknesses optimized and actually reduce the weight of the overall machine.
Yeah. Especially when we are comparing it to the Titan 1, what we had an own weight of 4.8 tons with only 1 ton on payload. Now we have 1.5 tons of payload and reducing it 100 kilo. So that was tremendously with that double link arm possible.
Yeah, that's obviously a huge advantage. So this type of machine, where is it going to be found? What sort of manufacturing environments require a machine of this sort of capacity?
So KUKA, especially known out of automotive section industry, that's also where we have that one. We have shown it last year, Automatica, with a car chassis mounted on. mounting chassis from A to B. What is also especially, it's the electric car market. So batteries are getting bigger and bigger, have to be included somehow into the cars. That's something. But also electric branch in total. So we have like big batteries, even for house system, photovoltaic system, everything which is handling in this case, and also our aerospace, big range also needs to be.
One of the things I was thinking about for the automotive industry is there's a big shift at the moment in chassis manufacturing, moving from welded steel assemblies to sort of giga castings. So I imagine those castings would be, they're quite big, they're quite heavy. Yes. I'd imagine they might fall into the remit.
Yes, definitely. So like the giga casting definitely is one what we are looking for, like what with this robot will be placed. Maybe not the 1500, but especially then also the long arm versions with the KR1000, 4.20 meters in reach, because these casting parts are big, are like super, I would say, complex to handle them, must be maybe shaken out and take out. There, this 4.20 meters brings us in a good position, definitely.
Yeah, brilliant. Okay, fantastic. I think that covers most of the design and applications and speciality of this machine. So I'd like to thank you both for your time and wish you a good show. We are here on the Filtermist stand, and I'm with Peter. And we stopped here because we saw this poster in terms of energy saving and supporting sustainability goals. So what I was looking for was an explanation of kind of what problem would an engineer be facing for this to be the solution, and how does it work?
Sure. Okay. So local exhaust ventilation, essentially in the manufacturing industry, when you're machining using mills, lathes, any kind of equipment that needs coolant in the process, that coolant is used between the machine tool due to the heat and the temperature. That oil atomizes onto the air. It produces oil mist. Oil mist is a breathing hazard, and it's also a flammable risk, and has a number of other reasons that it needs to be controlled. Under health and safety legislation, HSG 258, it's the owner's responsibility to protect their operatives from this oil mist. Local exhaust ventilation, or LED, is one of the options. It's the most popular solution to deal with that. Filtermist is the market leader. It's been in business since 1969, mainly using this type of machine that pulls the oil mist out of the machine tool cabinet, separates the oil from the air, returns the oil back into the machine tool or to a separate collection vessel for disposal, and the air that comes out of the top is approximately 99.97% clean. So that's what local exhaust ventilation does. When it comes to energy saving, we have this new product we've only launched since October last year. It's called the F-Save. With the filter, with the extraction system, it needs to be on when the machine tool is on to carry out the extraction. There is an energy cost to that. It's got a motor that's running. One way to save energy is to control when that the Filtermist local exhaust ventilation is on or off. We only need, so you can see here, this is the coolant. This is an image of the coolant. You only need to extract this when it's being used. Yep. That is not necessarily used during the life cycle of the machine tool. So what we have, we put a sensor on the coolant pump. This little chap here, it's connected to the coolant pump on the machine tool. Okay. When the coolant is activated, it sends a signal to turn on the filter machining. When the coolant is then not being used, it sends a signal back to the filter machining, puts a delay on it of about 5 minutes so that all the excess of oil mist is removed, and then it switches the filter machine off. And so it's only being used as and when it's needed. On a machine tool that's being run, it saves approximately 50 to 80% of the energy of the filter mist. And so over the lifetime over the year, you're looking at significant monetary savings, carbon footprint savings, and also, as a side effect, the operative doesn't need to remember to switch it on, switch it off, so they're always protected. You're taking out some of the human error.
That's fantastic. It seems so logical.
Yeah.
You wonder why everyone's not doing it, so that's a fascinating thing. I was thinking maybe some additional benefits. I mean, if the machine is not running continuously, then maybe reliability and durability of the unit because the motor's not running continuously and getting hot. So maybe some added benefits there as well.
Yeah, so the Filtermist unit, there are internal consumable parts that have approximately 2,000 hour shelf life. And the less you're with it being switched off, there is a reduction, it extends the lifetime of those plants as well. But the main saving is it's just saving energy costs for the life.
That's fascinating. It seems a fairly simple hookup to the coolant pump. Are there different interfaces that people would need to?
No. It's entirely. It has no. You don't have to fit into the machine tool at all.
Right.
It's all there, so you can be retrofitted to existing Filtermist units by anyone who's got a decent amount of knowledge, and we recommend that it's fitted with every Filtermist unit moving forwards, as long as coolant is being used in the system. Yep. So the sensor is attached to the coolant pump, the cable is connected to the F-Save, which is connected to the Filtermist, and it's completely separate to any of the operation of the machine. So you're not interfering with the cabin.
Right, well, I think that's a perfect explanation for our visitors and readers. So thank you very much, Peter, for your time.
Thanks, Peter.
And all the best. I'm on the SMC stand and I'm with Greg, and we stopped here because of the posters relating to energy efficiency and waste reduction. And we were directed to the air management system, and I'm now going to ask Greg, what problem would an engineer be facing for this system to be the solution?
So what we're really looking at here is leaks and also machines being left running and compressed air continuing to blow out when it's not needed. Right. So with a system like this, we can look at what the machine and a production line is doing, and if the machine comes to a stoppage and the compressed air isn't needed anymore, this will monitor, see that the air is no longer, get the signal, see the air is no longer needed. The first stage, it will reduce the pressure down. Right. And after another dwell period, if nothing's changed and it hasn't got a signal that it's back up and running, would actually then close the air off completely. So if there's long periods of machine downtime, you're not wasting all that compressed air at the same time.
That's interesting. So I'm guessing this system is communicating with the machine in some way, because it's going to need to know what mode the machine is in. And when it knows what mode the machine is in, it can then respond accordingly. Yeah. So how's it communicating? Is it wireless? Is it wired? How does that work?
Great question, John. So this includes our proprietary wireless technology. Don't think of it as Wi-Fi. This is that we use radio signals. It's something that SMC developed ourselves with a major automotive end user, initially to get comms cables out of the picture, but we've implemented the wireless into our air management system. It's all IO-Link based, so it works across a variety of communication protocols. So yeah, we can communicate with the machine, we can get signals when it's stopped running, machine signals to say it's back up and running. We can get a lot of data out of it as well. So fantastic for production reporting, energy usage. We don't do the dashboarding software ourselves, but that's something that we can liaise with the customers and make some recommendations.
Yeah, brilliant. Okay, that all makes sense. Why wouldn't you do that? It seems like the obvious thing to do. If a machine is in dwell, shut the air supplier, comes back online, put it back on. So could you just talk us through some of the components here and what their role is in the functioning of the system?
Absolutely. So there's three main parts. So we've got the regulator, so that's going to be bringing the pressure down. You can see we've got the readout there on the monitor. That's the wireless section, and we've got the shut-off valve as well, which you've just heard that trigger off.
Yeah, okay. Yeah, so from the pneumatic systems I've worked with, fairly standard setup, but it doesn't look like the regulator control valve units I would have originally seen. So this is the modern digitized version of what would have previously been a mechanical system. Yeah.
Yeah, so it's very much it's all the digital control of it. What you might be missing from what you'd normally expect to see is the filtration. Of course, filtration would still be part of this. This is all about the communication and looking at the air pressure, reducing it down, and then shutting it off.
Yeah, brilliant. Yeah, that all makes sense. That is now clear to me. It's pretty logical, and as I say, why wouldn't you do that? So, yeah, Greg, thank you very much for introducing us to this system, and I'll now go away and introduce this to my readers. Thank you very much.
Thanks so much. Thank you.